everyone! Happy calculus! So today we are going to learn how to do integration by substitution. So I'm going to be doing the first few examples in your notes and showing you step by step exactly how to do these problems. So we are going to start with our first example, which is the integral that is on example number 1 in your notes. So you can follow along in your notes, and then there is a written out form on Google Classroom as well. So the important thing to know about integration by substitution is that this integral is super complicated. There's obviously no easy antiderivative for this integral. So when you're doing substitution, you want to find an easy way to do an integral. So what you're looking for is something in the problem that is the derivative of another part of the problem. So usually, the reason it's called U substitution is you're trying to find something to let U equal. Usually the thing that you're going to pick to be your U is always going to be something raised to a power. So it's going to be a quantity that is raised to some sort of a power in the problem. So in this case, this guy right here that's being raised to a power is going to be the guy that we're going to let be U. So U is going to be equal to x squared plus 1. So the key now is that we have to set up like a chain rule type of situation. So every time we see a U, we have to then set up a du. So what we're actually doing is we're taking the derivative of u with respect to x. So if we did that on this side of the equation, we'd take the derivative of u with respect to x, and that would be equal to 2x. Okay? Well, we want to now rewrite this entire problem, substituting in everything that we have. Okay? So if you look, obviously we have the guy that I underlined, that's u. Okay? So if we rewrite our integral now, we would have the integral of u squared. Okay? But the key now is that we also have this other stuff in the problem. Okay? We have this 2x and this dx. Okay? The 2x, you'll notice, happens to also be what the derivative was of our u term. That typically is how these problems work. You're going to have some derivative in the problem that also matches up with your inside function. Okay? So we're going to do a little rewriting right here. We're going to move this dx to the other side. So we're going to write du is equal to 2x times dx. Okay? Now this is exactly what I have written up here in my original integral. Okay? So now I can make an additional substitution in my integral. So now I can replace all of my 2x dx with what that's equal to, which is du. Okay? So now I have a really simplified integral over here on this side. Okay? I have the integral of u squared du. So now I have an entirely new integral written with respect to u. And we know what the antiderivative of u squared is. So I can go down to my third and final step of this problem, which is now taking the antiderivative of u squared. Okay, so now I'm actually going to take the antiderivative. Okay, the antiderivative of u squared is u cubed over 3. Okay, and now I just substitute back in what my original u was. Okay, so my original u in the problem was x squared plus 1. So my answer for this problem would be x squared plus 1, that quantity to the third, all over 3 plus c. Okay? The reason it is a plus c problem is because this is an indefinite integral. And as an indefinite integral, we obviously have a plus c. There's no bounds on this integral, so that's why we do what we do. Okay? Let's take a look now at example number 2 in your notes. Okay, we're going to go through several of these kind of together to kind of see how you're doing. See what we look like on this lovely snow day here. So example number 2, we have the integral of 5 cosine of 5x dx. Okay, so here's our next integral. Okay, so we did one like this actually in our notes and things up to this point. Okay, we just didn't set it up as a substitution problem. Okay, substitution makes this integral a little bit easier to understand. Okay, this time it's not a power. Okay, we're now looking at just what's on the inside of the integral. So we're going to let u in this case be equal to 5x. Okay, and we picked that because that's what's on the inside of the parentheses. Okay. So now we're again going to take the derivative of that u with respect to x. So the derivative of u with respect to x this time would just be 5. Okay? As always, we're going to do a rewrite of this part because we want the dx over on the right-hand side. So my du will actually be equal to 5 times dx. So I'm actually moving that dx over to the right-hand side. Okay? So some of you will actually start to probably get in the habit of just writing du equals something dx. You won't actually put du with respect to x because it just gets a little tedious. Okay, so we've done all the hard parts of our problem, so now we can actually set up our problem. So our inside part right here, when we rewrite our integral, this is going to be the integral of cosine of u, right? Because 5x was what we substituted as our u. Okay. For this specific problem now, here is our du, 5 dx, and we have that part right here. Here's the 5 and the dx. So all of that is going to get substituted as the du. Okay, so now we just have the integral of cosine of u du. And again, we know that antiderivative. Okay, the antiderivative of cosine is sine of u plus c. Okay. And now we just make that final substitution by replacing our u with what it was originally in the very beginning of the problem. So my answer here for example 2 would just be sine of 5x plus c. Okay. Pretty easy process. Okay. Let's go through example 3 right now. On example 3, we have the integral of x times x squared plus 1 to the second power dx. So this one's going to actually be set up a lot like example number 1 was in terms of setting up our u. So again, we're going to go what's raised to the power. So we're going to start with what's on the inside. Okay? So u here will be equal to x squared plus 1. Okay? So our du this time, so the derivative of u with respect to x will be equal to 2x, right? Because 1 is a constant, so that goes away, just like last time. Okay. So when we move that dx to the other side, we would have the derivative of u is equal to 2x dx. Okay. Now this one gets a little bit trickier in terms of setting up our new integral. So when we move to set up our new integral, we have the integral of, okay, we again have u squared, just like we did in example number 1. Okay. Now, this one changes slightly. Okay. On the outside, we have an x and a dx. Okay. When we look at our substitution down here, we do have x dx right here, but we also have this 2 in front of that. Okay. We don't need that 2 for this problem. However, that is just a coefficient, so we can get rid of that. So we're going to make a substitution. I'm going to divide both sides by 2. So 1/2 du will be equal to x dx. So I'm going to put that 1/2 in front of my integral and now keep my du. So there are several times where we have to manipulate with our integral in terms of a coefficient when we don't have exactly the right number that we need. Keep in mind our same rules apply that have applied all year. We can divide by numbers, we cannot divide by polynomials. So if we were missing an x, we could not use this method. Here we have to have that coefficient of x right there. Now we take our antiderivative just like before. So we're going to take the antiderivative of u squared, which is u cubed over 3. We have the 1/2 in front, so we're going to end up with u cubed over 6, and then plus c. Okay. Our final step now is to just plug in our group. Okay. So my answer here for example 3 is x squared plus 1 to the 3rd power all over 6, and then plus c. Okay. I'm going to go ahead and pause the video right here, upload this part of it to YouTube. Okay. This is going to be phase 1